find the derivatives. On the first one, we have negative 2 times e to the x plus 7 times ln of x. So we'll take derivative. E to the x, derivative of e to the x is e to the x, and then the negative 2 multiplied to it, the constant multipliers will stay. Next, we have ln of x, derivative of ln of x is 1 over x, and the plus 7 is the constant multipliers will stay. So we just need to multiply the 7 on the top. So to rewrite this, we have negative 2e to the x plus 7 over x. So that's the first one. The second one, x to the fifth minus ln x cubed plus e cubed. So we just take a look at the derivative first. X to the fifth, that's easy. 5x to the fourth, ln x cubed, there's a problem with that. We'll talk about that in a minute. So this is a constant, and the derivative of a constant is 0. So the derivative of e cubed is going to be 0. Right. So we have to take care of the ln x cubed first. So first thing we do is to rewrite the function. So we don't take derivative yet. So the function is equal to x to the fifth. What we do here, we'll take the third power outside. So it will be an exponent, the coefficient 3 ln of x plus e cubed. So we haven't taken derivative yet. We just rewrite the function. Now we'll take derivative. We could write dy over dx, or we can write y prime. Either way, it's just a notation of derivative. Right. Derivative of x to the fifth is 5x to the fourth. ln of x is 1 over x, and e to the x, that the constant derivative is 0, right? We still have the minus 3 times 1 over x, that the constant multiplier, and then the plus 0. Right. So once again, x to the fifth, derivative of 5x to the fourth, ln of x, derivative of ln of x, negative 3 multiplied to it, so it will stay negative 3 multiplied to it. Finally, we have 5x to the fourth minus 3 over x. Next, we have negative 5 times 3 to the x power minus 5 times x cubed. So the important things here is to recognize the difference between the 3 to the x and x cubed. One of which, the first one is x on the power, so that exponential rule, and the second one x on the base, so that is the power rule. Right. So we'll take derivative. Three to the x power. X is on the exponent, so this is exponential rule. We will write 3 to the x power and then ln of the base. So that is derivative of 3 to the x. The negative 5 in front of it will stay. Right. And then next, 5x cubed. That's just a power rule. But we can just say x cubed, derivative of x cubed is 3x squared. And then the negative, and then 5 times will stay. And then to rewrite this, we have negative 5 times 3 to the x power times ln of 3. Notice that we cannot multiply anything. the negative 5 and 3, we don't multiply to it. This is different though. 5 times 3, 3 doesn't raise to any power, so we can multiply those two. Here we have the x as a power. We cannot multiply 5 and 3. We cannot do that. So 5 times still stay. Here we have negative 15 x squared. Right. We could stop at that step, or if we want to, we can put the ln of 3 in the middle. And then we have 3 to the x power. And then minus 15x squared. Right? Now to the last one. F of x equal to that. So we can write derivative. Right. Log base 3 of x. That log rule. Square root of x. We can rewrite that as a power. So before we take derivative, so we don't have the derivative yet. We just rewrite the function. So this is still log base 3 of x. Square root of x. Let's write x to the 1/2. Then we can use the power rule. Now we can take the derivative. Derivative of log base 3 of x is 1 over x times ln of the base. So that is derivative of log base 3 of x. And then we have minus 7 x to the 1/2. Derivative power rule is 1/2 x to the negative 1/2. So we have 1 over x ln of 3. We can put negative 7, I mean the 7 multiply on the top. We have negative 7 over 2. The x to the negative 1/2 move to the bottom, become x to the 1/2. So that's all we have.